So you say, supercomputers, that's great. So what are they actually used for? There are more uses than I could possibly mention in this video, but I definitely wanted to hit on a few that I've actually seen in my career. Of course, the more esoteric and theoretical side of things, study the quantum characteristics of atomic structures and model new chemical compounds and crystalline structures. Someday, these materials that are being modeled in these more esoteric and theoretical use cases could be used in everything from clothes to beauty products to building materials to even the next generation semiconductors. Another use case I'd like to mention that is a little far off and may not have an impact on your daily lives. High-performance computing and supercomputing is essential to the study of the Big Bang. Researchers use particle accelerators in order to smash subatomic particles together. That generates massive quantities of data. And without supercomputing and high-performance computing, the analysis of that data would be nearly impossible. There are many practical and tangible use cases for supercomputing. Weather forecasting. The same forecast that you get from your nightly news, or even look up on your phone every day to make sure that you can put on those shorts or wear your flip-flops or carry an umbrella. The other type of weather forecasting that supercomputers are used for is space weather or solar weather, predicting and analyzing coronal mass ejections or other phenomena coming from the sun. These predictions help scientists and researchers project what impact those coronal mass ejections, or CMEs, are going to actually have on Earth, on our infrastructure, on satellites in space, and what it's actually going to do to our weather. The next is climate modeling. It seems to go hand in hand with weather forecasting. However, they're quite different. Climate modeling uses complex mathematics in order to predict how the climate is going to change on a global scale. The next is earthquake modeling. Scientists are looking for a way to predict when that next big earthquake is going to happen. There's another one that probably has an impact on your daily life: oil and gas exploration. I don't know of any oil or gas companies that do not use supercomputing in order to help them explore for oil and gas. Another use case for supercomputers is financial systems modeling. Market analysts actually use supercomputers in order to help predict what the markets are going to do. There's another side to this. Trading companies are using high-performance computing and high-speed networks in order to give them an edge over their competitors who are doing things the old-fashioned way. Since the 1960s, nuclear weapons testing has been banned. Engineers use supercomputers in order to test the viability of those nuclear weapons. The next use case is industrial and mechanical design. Aircraft and automotive manufacturers use supercomputers from the design and testing phase of their products. Many of these same manufacturers do not have wind tunnels anymore. Wind tunnel tests are now simulated inside of a computer using computational fluid dynamics. The next use case is life sciences, something that's near and dear to my heart since I've spent the last 10 years working in life sciences. Drug discovery, researchers using supercomputers and high-performance computing to fold proteins in order to make sure that those drugs are actually going to bond where they need to bond. Cryo-electron microscopy, light sheet microscopy, and future types of microscopy that are generating massive amounts of data. And without supercomputing and high-performance computing, we wouldn't be able to analyze that data. Last but certainly not least is genomics. Genomics has played a large part in our lives, whether we know it or not, in the last 2 years. Genomics has been widely used to study the coronavirus. Without high-performance computing, we wouldn't have been able to analyze all the data that's been generated since the beginning of the pandemic. The next is movies. Supercomputers were used to render at least portions of your favorite explosion, or your favorite car chase, or that epic battle with tens of thousands of soldiers or creatures of whatever kind all over the battlefield. One use case with very little known about it is sports. There are reports that a few Major League Baseball teams have actually purchased supercomputers to do deep, large-scale analytics on all the data that they collect during games. Player statistics, crowd statistics, or revenue stats, or environmental conditions, or something that's called the field effect. If you are into physics and you are a baseball fan, then I highly encourage you to visit the Physics Baseball website of the University of Illinois. You will not be disappointed. So, Procter & Gamble, the maker of Pringles, that's right, the potato chip, had a problem with their potato chips flying off the conveyor belt. Apparently, enough chips flew off the conveyor belt that they decided to use their supercomputer in order to model the aerodynamics of the Pringle chip. Their findings from the models allowed them to change the shape and the aerodynamics of the chip so that no chips would fly off the conveyor belt anymore, saving countless lives. Chips. So I've given you the history, I've given you use cases, but I'm sure you're probably still asking, well, what is a supercomputer?